All right, so what I want to do, I just want to pull up a practice test. And so you notice if you go to practice tests, I've added a practice test for module 2. Okay. And it's 13 questions. I think you're going to agree this is much easier than the other stuff. There's much less to cover. So right now, let's get headphones away. Let's get phones away, all that good stuff. Okay, so choose the graph of the absolute value function. All right, so you're going to have a few of these where you're given a function, you've got to select the graph, right? Oh, whoops. Thanks. There we go. Okay, so so you're given a function, you have to select the graph, okay? So then real quick, how do we do that, right? Let's remind ourselves what transformations look like for absolute value functions. So if we start with the parent graph, just the plain old absolute value of x, what does that look like? What's the shape of an absolute value graph? What's it look like? It's a V, right? It's a V, and the vertex is located where? Wherever it says. But if it's just like this, it's going to be at the origin, right? Okay, so if we were to graph this, it would just look like that, right? Okay, Ken, I want you to focus on this. We gotta get this down. Test coming up Friday on this stuff. So here's the V. Okay, so what does this do? We've got these 3 parameters, A, H, and K. They do the same things for an absolute value function that they do for anything, right? But it's easier for an absolute value function. What does H do? What's it always do to a function?
Moves it left or right.
Okay, horizontal translation. K is
Up or down.
vertical translation, up or down. But there's really only one point on the absolute value function that we're able to track really well. What is that? Yeah, well, it's that point, right? The vertex. All the other points just kind of, they're hard to see because they're just parts of rays, right? But this one is really easy to find. So if we start with the vertex at 0, 0, and we move it right by H and up by K, yeah, those are translations, but doesn't it end up really just being the coordinates of the vertex, right? So if we end up translating this thing, so let's say it goes over here and it goes up to there, that's H and that's K, then that's our new vertex, and its coordinates are HK, right? So all we got to do with these numbers is just put a point where we know the vertex is going to be, right? What did we say that A was? Okay, A is always, we know what that is. In general, what is that? When we talked about transformations, what did A do? Say it again. Vertical stretch or compression, right? And if it's negative, it was a reflection, right? Made it up, flipped it around. Okay, so what is that? Same thing for an absolute value function, but because of the shape of an absolute value function, there's an easy way to deal with this. This is a line, right? Or it's a ray, but I mean, it starts at the vertex and it's linear from there. So all we'd have to do is say, okay, if I'm going to stretch this thing, it starts off with a slope, I go over by 1. I rise, I should do it this way. I rise by 1 and I run by 1. The slope is 1 to start with for a regular absolute value function. If I stretch it by a factor of 3, let's say, what's that doing? Well, it's just going to take this line and it's going to move this point that used to go up 1, it's going to move it up 3, right? So really what this ends up being is just the slope of the right leg of the V, right? And that's a great trick. And it works if it's negative too. If it's negative, then we would just start by rising down and running, right? So that's a really easy way to connect the graph of an absolute value function to the function, okay? So let's try that then. If we look at one of these problems, like this guy, this time we're given the function. So we've got to just compare that to our parent function, right? So let me go back. Well, I'll just cut this thing. How about it? Okay, so how about this then? if I make those, if I compare those, I just have to determine what are the values of the three parameters. Well, what's a in my function? It's -1, isn't it? Because it's the number that's being multiplied by the absolute value. Well, there's a negative sign there. What's the negative sign really mean? -1. Yeah, we're going to flip it. But as a number, it just means it's -1. We don't write a 1 coefficient, right? So a is 1. What is h? 0. How come it's 0? You're right. Because there's nothing there. And if there's nothing there and h is being added or subtracted, it'd have to be 0, wouldn't it? Right? Because adding or subtracting 0 would leave the x by itself. So h is 0, and what's k? 2. So then we've got the coordinates of the vertex are 0, 2, right? And the slope of the right leg is +1. Okay? We just have to go find that graph. So what's that going to be? What did we say? It was 0, 0, 1, right? Or 0, 2. So that's negative, so that one's not going to work. That one's not going to work. That one's not going to work. That one works. 0, 2. But we said a was 1, so the slope of the right leg needs to be 1. Is that 1? That's -1, isn't it? Because we'd always start at the vertex, and we're going to go down. In this case, we rise by -1 and run by 1. So for this graph, a is -1, so that's not it. You got to keep going. Or was it negative? Oh, it was -1, wasn't it? Yeah, it was. Sorry, I lost track. It was -1. This is the one that matches. This is the one that matches a vertex of 0, 2, and a equals -1. Because starting at the vertex, we rise by -1 and run by +1, right? So our slope is -1. Questions? Okay. How about that one? Real quick, just look at that for a second. In your notebook, just jot down what you think A, H, and K are. Let's see if we can find this one real fast. Okay. All right. Everett, what'd you get for A on this one? Okay, where would A be? Okay, it's in front of the absolute values. Well, there's nothing there, right? Okay, good. That's what I want to get to. So is it 0? Well, now, it's different than an H or a K. A is being multiplied by the absolute value. So if something doesn't show up, let me give you just a different kind of example. What if I had something like this? What if I had something like x, what if I had the line y equals x minus 3? The slope is the coefficient of x, right? So what's the slope of that one? That'd be 1, wouldn't it, right? If there's nothing in front, if there's no coefficient, there's always going to be, if I'm multiplying, there's an invisible 1 there that we just don't write. And there's a lot of that stuff. We do, like if I write a power, x is really to what power? Well, it's really to the 1 power, but we just don't write it. It's not necessary, right? So there's these invisible numbers pop up all the time that are implied. For multiplication, it would be a 1. For addition, it would be a 0. Okay, so what's A?
1.
It's 1. Okay, good. So A is 1. And what is H? You gotta be careful with this one too. What's H? What do you think? It's 3. It's not -3, right? Because H is what is being subtracted from X. So just like we've always done with transformations, remember that H is going to have the sign that's opposite of that, right? So H is 3. What's K? 0. Now you see why k is 0? Because k is being added. And so if there's nothing that's being added, then that would be 0. This goes all the way back to Algebra 1. We said that the identity number for multiplication is 1, right? 1 is the number that I multiply something by to keep it the same, right? So I'd multiply this by 1 and not change it. 0 is the identity number for addition, right? So if I'm adding or subtracting, and I want something to, if something's invisible or it's not changing, then I'm adding or subtracting a 0, right? So I've got to find then I've got to find the graph that has a vertex. What are the coordinates? Hannah, what are the coordinates of the vertex going to be then? If those are the values of the parameters I've identified, where do I look for the vertex? In what ordered pair? Okay, Carolyn? Where's that going to be? Okay, think back to this, right? We said that the coordinates of the vertex are HK, right? So where's it going to be? 3, 0. Yeah. So we got to go over 3, up 0, and the slope of the right leg is just going to be 1. Okay. So that's not quite right, is it? That's the wrong slope. Tell me when we get there. Right there. Coordinates are 3, 0, right? And the slope is positive 1. Rise over 1 is run as 1. Okay, that's it. All right, let's do one harder one, and we'll move on. Try that guy. Okay, everybody write those down. Write down the values of the parameters. Okay, Mallory, what's my value of H? 5. Good. What's my value of K? Okay, so then the coordinates of the vertex are?
5,
Good. 5, -4, right? Okay, so there's the vertex. Nick, what's the value of A?
-3.
Okay, good. So then we know that if A equals -3, that's going to be the slope of the right leg, right? So we just got to go find that one. So 5, -4, that doesn't work, does it there? Okay, let's just find the right one. Tell me when you think we got one that's a winner. That looks promising, right? If I go over 5 and down 4, that's good, because that puts me at the vertex right there, right? There's the vertex. Now what about the slope? Well, I'm going to rise by, oh, I can't do that from here. I'm not that talented. So to get from the vertex to the convenient point, I'm going to rise by -3 and run by +1. So the slope would be -3 over 1, which is -3. So that's it, isn't it? Right? Okay. All right. So now, something different. Let's just go right to a hard one on this one. So this time we want to do the opposite. You're given the graph and you got to write the function. But it's the same thing, isn't it? This time you're going to you just want to find the values of A, H, and K and just plug them in, right? We're going to do it by looking at the graph. So by looking at the graph here, Jace, can you tell me what are the coordinates of the vertex? What's that going to be? You gotta look
Can you
closer.
zoom in just like a hair?
What's that?
Can you zoom in on just like a hair?
Yeah, oh, sure, you bet. Can zoom in more than that. Coordinates of the vertex, that help?
7.
So, there's the origin. I'm looking for the coordinates of that point.
Oh.
I think you're looking maybe wrong. So we're looking at the coordinates of the vertex, right?
2 and 4.
Yeah, 2, 4, good. Okay, good. So what's h? You told me, right? The coordinates of the vertex are just h and k, right? Because that's how far it's been slid. Okay, everybody see that? So h is 2, k is 4, right? Very good with that? Tyler, what's a? What's the slope of the right leg? So start there, right? Start at the vertex and go left to right.
Would A be negative 2? You're going over 2, right? Is an opposite.
Okay, but I gotta do rise over run,
Oh, yeah,
right?
just slope.
I'm just doing slope, that's all.
3 over 2.
So I'm rising by 3 and I'm running by 2. So A is just rise over run, right? It's a slope. So 3/2, right? So all I've got to do then is just plug that stuff into my template. Well, what's my template? My template is just A times the absolute value of x minus h plus k. So let's plug that stuff in. Well, A becomes, I'll replace A with the fraction 3/2. I replace h with 2, and I replace k with 4, and that's it, right? And that's the hardest one of that series, okay? So if you can do that, you can do all of them. Okay, what about these? We're going to solve some absolute value equations. To solve absolute value equations, remember that this is, and by the way, this handout, if you guys want to see this stuff, what's going on? Oh, oops. If you guys want to see this stuff, it's on, if you go to the Algebra 2 page, oops, and you just go down to Unit 1 Resources, which is right above Unit 1 Practice. These are just documents that you can either pull up as a, pull up online, or you can download them if you want to. So there's absolute value equations and inequalities right there, right? And that gets you to this right there. Okay, so Bailey, now what are we going to do if I have an absolute value of something? Do you remember what my strategy is? Right, I can't solve the equation with absolute values in it. What do I have to do? Remember? Yeah. I've got to take away the absolute value bars, but the way I do that is by making a trade, right? So I've got to trade. Once I get it like this, now I have to get to this point where I've got the absolute value isolated on one side of the equation, right? I have to do that. But once I've done that, by maybe adding or subtracting terms to both sides or something, once I get it looking like this, where I've got the absolute value of something is equal to a number, C, the trade I make is that whatever's inside the absolute value bars is either equal to C or it's equal to negative C. So I get two separate equations that are simple and I just solve them, right? So this one, the first one we're looking at is really extremely simple because there's the only thing inside the absolute value bars is the absolute value of x, right? So the trade I make here, I've got the absolute value of something equal to 18. So the trade I make then is just the absolute value of x equals 18. We trade for x equals 18 or x equals negative 18, and that's our answer, right? Just 18, comma, negative 18. There are two solutions. Okay, let's look at a little harder one.
Isn't there always two solutions?
Yes, There will always be two solutions unless it's like a really rare case where the two solutions overlap or something. Or if there's no solutions. What if I had the absolute value of x equals -9? What would the answer be? No solutions, because absolute value is never negative, right?
So
Okay.
do I have to do all that work, or can I just?
No, then you just put ns.
No,
right.
I'm just saying, did you have to do that to know that it's 18 and -18?
Not on this one, maybe. It's pretty easy, but what about this one? I'll give you another one where, yeah, maybe we couldn't just get the answers right away on this one. What if we had something like that?
Yep.
Okay, that one you wouldn't know the answers by looking at it. At least I would. Maybe you would. Okay, so once again, my goal is I want to be able to make the trade, right? But I can't make the trade yet. I can't make the trade until I get the absolute values by themselves, right? So Kylie, what am I going to have to do first to get those absolute values by themselves? I've got to add 7, don't I? Right, because look, I've got to get, this is the part that I've got to isolate. Well, let's just talk about that just for a second. That might seem kind of strange, right? It might seem like that's a really hard thing to do. It's not. Isolating something is the same regardless of whether it's a single variable or an absolute value expression, right? When I isolate something, if you're ever unsure what to do, you just go backwards through order of operations to isolate, right? So the first thing, if I'm trying to isolate this, then I have to undo any addition or subtraction, right? Well, we're subtracting 7 from it, so we would add 7. So that goes away, and we end up with the absolute value of -3x plus 9 equals, what, 36? Okay, now we got it, right? We got the absolute value isolated, and so we make our trade. And then this becomes easy. So the trade is going to be what? What's our trade going to be here? Vanessa, what's our trade going to be? If I got the absolute value of something equals 36. Say it again. Right, so what's equal to that? You're exactly right. What do I say equal to that? Not x. No, it's got to be whatever's inside the absolute values. Because with our job now, we're making the trade to get rid of the absolute values, right? So whatever's inside, whatever's in the blue bubble, is either going to equal 36, or whatever's in the blue bubble is going to equal -36, right? So we get the equations -3x plus 9 equals 36, or -3x plus 9 equals -36, and those are easy, right? Those are two-step equations. What do I do to get the x by itself here? 2 steps? Subtract 9, and I get -3x equals 27. Divide by -3, x equals -9. Same stuff over here, right? Subtract 9. Divide by -3, and x equals 15. So those are my solutions, right? On a test, how could I check them? Plug them in. Just plug them into the original and see if
How did
they.
you get 45 and 27?
How did I what?
Oh, negative, okay, just kidding.
Oh, because I subtracted 9.
From negative.
Yeah, from -36. Yeah. Okay? All right, so that's how we deal with absolute value equations, right? We isolate the absolute value, and then we make our trade. Okay? What about inequalities? Same kind of thing, right? With inequalities, there's 2 possibilities. I got to isolate the absolute values, like always, but once I've done that, if I end up with an absolute value expression that's less than a number, we make this kind of a trade. We trade for these 2 inequalities that are merged into an AND inequality, where there's a lower limit and an upper limit, right? So it's bounded on both ends. Or one like this: if the absolute value is greater than a number, then that's extreme. right? That means that what's inside the absolute value is big. It's either gonna be very positive or it's gonna be very negative. So it's either greater than C or less than negative C. How do you remember that? I gave you a little trick yesterday. You take it or leave it, but the three possible things that we're dealing with: one absolute value equation, two kinds of inequalities. Look at the outcomes. Two of them give us or answers, right? Two separate equations or inequalities that we solve separately. One of them gives us this and inequality, right? Where it's something in the middle and a lower limit and an upper limit. The oddball one, the one that gives us the and, is the one that the absolute value sign points at. It's like an arrow pointing at the oddball one. That's the and, that doesn't use or, right? So let's do one of those. I'm just going to jump right up to a little harder one. Like that, maybe? Is that? Yeah. Okay. Okay. Actually, I kind of want a different one. So you know I can redo these, right? On these, I set this up so if you either miss it twice or you get it right on the practice tests, you can, oh, what? I didn't, but I will. Oops, that's not what I want. No. Yes. There we go. Okay, now you can redo these. If you want to get more practice on one type of this, I'll show you. So if I don't like that one, let's say I did that one, or I want to get a different one, I can just either get it right, or I can try again and get it wrong twice. And then it gives me the option to redo the question. And if I hit redo, it keeps the rest of the practice test the same, but it just gives me a new question for that part. Okay? Make sense? Okay, so what about this one? Let's look at this guy. I like this one. Okay, do I have to do any work to get the absolute value bars by themselves? Nick, do I have to do anything? No, absolute values are already isolated on one side, right? There's nothing being multiplied by the absolute value or added or subtracted from it, right? So I can just go directly into making my trade. Now this is the one where the inequality sign is pointing at the absolute value, so what kind of trade do I make? Angelica, do you remember, what kind of trade do I make? What do I do with what's inside the absolute values here, right? Because I'm getting rid of the absolute values with my trade. Okay, this is the one, everybody remember? This is the one, I'm pointing at the one that doesn't use an or, right? So this is the one where I've got the argument of the absolute value, whatever's inside, is getting pinched between a lower limit and an upper limit, right? So there's no or. The upper limit is going to be 27, and the lower limit is going to be negative 27, right? So I made my trade. That is my trade. Now I've traded the absolute value inequality for a compound, meaning 2 and 1, regular inequalities. Well, how do I isolate x there? It's a little weird, right? But how did we do that before? How do we get the x by itself? What do I do?
33.
Okay, I got to subtract 33, but there's 3 parts to this, right? Does that make sense? So we're going to subtract 33. Okay, and if we do that, we get a negative 3x. Let's see, here we get negative 60. Here we get, what, negative 6? And my inequality signs just stay the same. They haven't flipped for any reason, so they just stay the same, right? Okay, Carolyn, what do I do next?
Divide by -3.
Divide by -3. There you go. So divide by 3. Now, I'm going to make the negative sign red because that's important. What's going, well, how come?
You flip this
I got to flip the signs. Good. If I multiply or divide inequalities by a negative, that means I've got to flip the signs. Now, what I do, that's the easiest thing to forget. So what I do is I put a circle around that immediately, and I flip them. Otherwise, I'm likely to forget, right? And then what do we end up with? Well, we got an x here. Negative 60 over negative 3 is positive 20. Negative 6 over negative 3 is positive 2. So that's my answer, technically. But if I input that, I'm going to get like half credit, and it's going to say that it's not formatted properly. What's wrong with that? What's wrong with that? Eli, what's wrong with that? What's the problem with that thing? Cassie? Yeah, idea? Anybody?
Are the symbols wrong?
Yeah, going the wrong way. Look, when I've got an and inequality like that, an upper limit and a lower limit, what has to be true about the lower limit compared to the upper limit? Yeah, it's got to go in numerical order, right? In increasing order. So the 2 has got to go there, and the 20 has got to go there, right? So all I'm really going to do is take this thing. Imagine this is written on a piece of glass. I'm just going to take this thing and do that to it, right? To flip it around. So if I do that, would you agree that I end up with the 2 there and the 20 there, and the x stays in the middle? What happens to the inequality signs? They got to get flipped, right? Because look at the relationship. X has to be greater than or equal to 2, right? And it has to be less than or equal to 20. So that's my answer, right? Okay, last one. And then I feel like you're good to go. Ready for this test.
Is this worth more than the other test?
No. No. But the second of the other tests is only worth, it's not worth very much, only 25 points. The one problem test. Okay, what about this one? So this is the one where the inequality does not point at the absolute value expression. And so this one is not the and, it's just a regular or one, right? Okay, so Eli, do I have to do anything to this to get the absolute value by itself? It's already done, good. So what's the trade I'm going to make? The absolute value is by itself, so whatever's inside, what do I do with that? Can make it an inequality. So 2x minus 2 is what? Remember?
Or.
It's going to be an or one, isn't it? We know that we're going to have an or, and this is the extreme one, right? The absolute value, we have to have a big answer to this because it's greater than, or the absolute value is greater than or equal to 6. So if it's already positive, then it's greater than or equal to 6, right? But what if this was a big negative number in here? What has to be true? You remember?
Be less than 6?
Less than or equal to negative 6, right? It's either got to be very positive or very negative, right? And then I just solve these individually. So what are, I mean, this is easy here. What are the 2 steps in order to get the x by itself?
Add 2 and count.
Okay, so if I add 2 to both sides, I'm going to get 2x is greater than or equal to 3 divided by 2, right? That's 4, whoops. No, that's 8, what am I doing? I was dividing. So I get x is greater than or equal to 4, or what's the outcome over here? If I add 2 2x is less than or equal to negative 4, x is less than or equal to negative 2, right? But the instructions say something about that. So we're greater than or equal to 4, or less than or equal to negative 2. Not and, it's an or statement, right? And we have to specify that. So if you go to the answer, it says, if the solution is a disjunctive, if it's an or inequality, use the or symbol, which is this guy, right? So we got to say x is greater than or equal to 4. Then if I go to the operations menu here, and if I hover over these, it tells me what they are, right? So if I go to this one, it says logical or. So that's the one I want. X is less than or equal to negative 2, right? Does that make sense? Okay, that's it.
Now, if you redo a question, can you, it's a
So-
practice test, so it doesn't matter.
Right, on the practice test. So if I redo it, say you want some more practice, if I hit redo, it'll load up a different one that's the same style. Okay? On the test, you won't have that option.
Yeah.
Okay? All right, how much time we got? 6 minutes. No sense. We're not gonna go anywhere. Any questions in anything? Any questions you want to go through in the last, like from the last test? The last couple minutes here. Okay, I will delete, remember yesterday was a free day for testing, so I'll go ahead and delete any tests that you don't want me to keep. And you can start fresh on Friday, okay?
So when do we need both tests done?
Well, I'll leave them open. We're gonna start new stuff on
Monday?
Tuesday.
Oh.
Monday will be Monday, I'll go ahead and make that like a makeup day.
Okay.
But we'll start new stuff on Tuesday, but I'll leave them open so you can still retest next week if you want it.